Okay, so we're looking at Unit 15, Day 3. This is extra credit. Obviously, if you are watching this video, it's because you're trying to earn a couple extra points and do the homework for this assignment. It's dealing with solids, ionic solids, metallic solids, molecular solids, network solids, and amorphous solids. Um, all of those solids in some way are going to make some form of crystal lattice, some sort of pattern in which there's some repeatable unit. And that's what the unit cell is called. You can see up here it says unit cell. It's the smallest repeating unit that has all of the symmetry characteristics of any solids arrangement. So it's that, if you think about back to tessellations in math, that tessellation piece is the same every step of the way. That's the exact same with the unit cell. We're going to get into some theoretics here. I think when you see the pictures, they're going to make a lot more sense. But we're going to look at different lattice points, corners of the cube that constitute the unit cell. It's actually how you tell what type of crystal something is apart. Before we do that, first thing we're going to do is draw ourselves a 3D cube. You can watch my amazing artistic ability as I'm going to cheat a little bit and make myself a square, right? So if I've got a cube, I want to draw a three-dimensional cube. Let's see, I will want to go to another cube up here. Draw this cube, and then I think I can move this cube just how I want it to move. I guess I want this cube. It's not going to be terrible. I'm going to wish I had more of a dotted line showing, but I'll go with it right there. And then I'm going to go back to my line drawing and say I'm going to connect that line to that line. So I'm dealing with a cube. Again, my artistic skills aren't the greatest. That's what the cube would look like. That's what we'd be able to see. And then would have a whole bunch of dotted lines that show, oh, this is where it's going to get real messy. That show the other parts of the cube that we can't see. So we're looking at, we take a compound and we cut a cube of it out. That unit cube or that unit cell would have all the parts of the repeating pattern. We could put those cubes together in any fashion, in any direction. We could stack another cube next to it here, stack a cube below it right here, a cube on top of it. Would have a repeating pattern. Now sometimes that cube has to be really big for that to be the case, and sometimes it just has to be really tiny. And we're going to talk about some of the unique types of cubes that you can actually see them over there looking pretty as can be. Some of the unique types of unique types of cubes that you are going to learn about. So we drew our 3D cube, got a view. You've hopefully printed these notes out if you're this far. Look at the 3 different types we're going to talk about. Now all this is going to sound like a bunch of mumbo jumbo until you actually see the picture. So we're going to start with a simple cube. In a simple cube, it's saying each corner is shared by 8 different cubes. So basically it's just at each corner of the cube there's one atom. And so 1/8 of that atom is within, because again we're in a 3D space, 1/8 of that atom is within the cube. Well, since there's 8 corners on the cube, oops, we'll go back a bit. Little quick there on the draw. Since there's 8 corners of a cube, in each corner has 1/8 of an atom, you're only going to have in a simple cubic shape 1 atom per cube. We're in a face-centered, again, here's a simple picture. We'll look at that before we talk about face-centered. So what that's saying is in this cube, well, if I cut off, looking at the cube, if I cut off just what's inside of it, tried to represent that, you'd see just 1/8 of the sphere would be inside of it. Now, if I put all these together, this would give me a hemisphere, this would give me a hemisphere. Together, they'd make one sphere, or one atom is inside that cube on a simple cube. Now, when we talk about a face-centered cube, it's just what it sounds like. There is an atom centered on each face of the cube and atoms at the corners, just like we just saw. Well, because of that, you have your 8 corners and 1/8 of an electron, or 1/8 of an atom each on them. But then you've got your 6 faces. But if there's an atom on a face, half of it's in one cube, half of it's in another cube. So that gives you 3 full atoms from the faces and 1 atom from the corners to give you in that unit cell just 4 atoms. And we'll look at a face-centered cube so you can see how that works. So what this is showing is these red guys on the corners are just like we just looked at. But now the white ones are all centered. Here, this guy's centered in the top face of the cube. This guy's centered in the back face of the cube. This guy's centered. You can kind of think about them like number 1s on a die, the one little dot there, right in the middle. So there's 6 of them because there's 6 faces of the cube. But if you actually just slice that on those lines, you'd end up with only half of that cell being, or half of that atom being in that particular cell. Of course, if I clicked one of these boxes right over here, then I would create a full sphere on this face, and again, some quarter spheres over here. So that's a face-centered cube. Again, if we go back and look, there are 4 atoms per cell. It's when you can get some pretty complex shapes. Then you have body-centered. Body-centered means there's one atom centered directly in the middle of the cube. One whole atom. And again, the picture shows that pretty clearly. You continue to have your 8 corners. So if we look at a body-centered, it's this white guy right here. He's smack dab in the middle. So really, if we think about what this possibly could be, this is some sort of positive cation, let's pretend, that is then surrounded by 1, 2, 3, 4, 5, 6. 1, back to this picture. Okay, this cation is surrounded by all 8 of these anions, and then the same thing down the way, down the way, down the way. Maybe he has a larger charge, so he pulls more things towards him. Again, if I was to slice along each of those lines, what I'd end up with is this one atom directly in the middle with all these 8ths of an atom, these little corner slices of an atom, all surrounded by it. That would be a body shape, or a body centered. Again, going back to our pictures, if we have body centered, there's going to be 2 atoms per cell, face centered, 4 atoms per cell, simple cubic, just 1. Again, if we add up all these pink parts, it just make one sphere, one atom. If we added up all these yellow parts in the body centered, would just get 2, the 8 from the corner and the 1 in the middle. Yet if we added up all these guys, would get the 1 from all the corners, and then the different cells from all the outer faces. So it'd have 1 here, plus the 1 on its opposite side that we can't see in this picture, making a full atom. This guy and the 1 of its opposite side that we can't see, making another full atom. This guy and the 1 on the bottom side that, again, we can't see in this picture, making the 3rd, adding it to the 1 from the corners, making 4 on a face-centered atom. Very, very straightforward. There is some homework questions that are going to get into what types you'd see, but I think these pictures will help you. You, of course, can go look at any time. We'll go ahead and see what else we can do here with our great artistic ability and draw you all a beautiful picture. See if we can figure out what it is, just for fun. Any guesses? Well, if you got it off this, you'd be a pretty smart person, but our class is filled with smart people. But okay, here comes the second part. Oh, you might start to have an idea. That is a doodle line. We don't really need him. Looking a little clearer, I'm going to give some definition here. This is one of my things I can draw. Ooh, that's a little big right there. And you might disagree when you see it in the end. You might be like, no, Mr. Atkinson, you can't actually draw anything. It's an awful drawing. But some of you might just be scared by the time I'm done. Scared of the picture, that is. So I'm going to fill him in with a little bit of red right in the middle, looking great. Then I'm going to get my paintbrush and a pretty big line here, get some white on that paintbrush, and give this guy some mean teeth. Roar, that'd be the noise he'd be making. And some more teeth down here. If you haven't figured out what it is yet, I'm quite insulted. Give him some baby blues and show him in his native habitat. Ta-da! Anyways, I hope you enjoyed. Obviously, this had nothing to do with simple cubic pictures. Just wanted to sketch a picture of a shark. It sort of looks like a shark. You gotta give you a little bit of credit. Now, if we can get that recording box to pop back up.